In this video, we are going to learn how to use the product rule to do differentiation. Now, when do we need to apply product rule? We use product rule to differentiate functions which look like this. When you have fx times gx. Fx is a function in x multiplied with another function in x, gx. Okay, so let me give some examples. So this is an example of when we shouldn't use product rule. If you look at this, even though it's a product, you can see that this is a number 2, that it's not a function in x. There's only one function in x. So in this case, we can actually do this differentiation even without product rule, using just the chain rule, because you have a function raised to a power 8. This 2 is a coefficient. I will just copy this coefficient down, bring the power down, power decrease by 1, and then differentiate whatever is in the bracket. So I can do this differentiation without product rule. As compared to this example, I have a function in x, 2x, multiplied by another function, x plus 3 power 8. So this is an example of when we will need to use product rule. Now, let us look at this equation. For this equation, even though it's a product of two functions in x, we are able to differentiate this by expanding this equation. So we will be able to get 2x squared plus 6x. 2x squared plus 6x is now a sum of two terms. So we can differentiate this by differentiating each term individually. So we will get 4x plus 6. Whereas in this example, 2x times x plus 3 power 8, we will not be able to do this expansion because this is a power 8. So unless you want to use binomial theorem to expand this out fully and then multiply the 2x to each term. So an easier way would be then to use product rule to do this differentiation. So now let us look at how to apply product rule. So this is the product rule. F prime x times gx. F prime x means to differentiate fx. Gx means we keep the gx as it is. Then we plus fx times g prime x. What does this mean? We keep fx as it is and we differentiate gx. So this is what product rule looks like. Now this is an easier way to remember product rule. I'm going to call this first function, the first function 1, and this one function 2. So basically product rule states that you need to keep the first function and differentiate the second function. Then you differentiate the first function and keep the second function. Okay, so basically the two functions will take turns to be differentiated. Now let us see how we can apply this to a question. So in this question, you can see that it's a product of two functions in x. There's no way for us to expand or simplify this. So in this case, we will need to use product rule. I'm going to let y be this function first so that I can use dy dx in my presentation. Now, if we don't let y be equals to this, then it will not make sense to write dy dx because there's no y in the equation, in the question. So, I'm going to call this the first function and this the second function. So, the product rule is I'm going to keep the first function as it is and I'm going to differentiate just the second function. Differentiating 2x cubed minus 5 will give us 6x squared. Differentiating minus 5 is just 0, so I can keep it as 6x squared. Next, I'm going to add the next part, which is now to differentiate the second function. Differentiate the first function and keep the second function. Okay, I prefer to always write down what I'm going to keep so I don't forget. So now 2x cubed minus 5 I will keep. Then I can differentiate x plus 3 power 4. X plus 3 power 4. So I will need chain rule to differentiate this. Bring down the power. Power decrease by 1. Then I need to differentiate whatever is in the bracket. So differentiating x plus 3 will give me 1. Okay, so this part here I needed to use chain rule. So this is actually the answer when we use product rule to do the differentiation. Now usually we will not leave the answer in this form. We will simplify this by factorizing out any common factors. So in this case, x plus 3 power 3 is common. 4 and 6 also has common factors too. So I can factorize out the common factors. So this will give us, inside the bracket, we will be left with 3x squared and x plus 3 in the first term. From the second term, we'll be left with 2x cubed minus 5. Now, whatever is left inside this bracket can be simplified. I'm going to expand what I have inside this bracket. You will notice that there are some like terms. There's x cubed here and x cubed here. So our final answer, we will be able to add together the like terms. So this is an example of how we can use product rule to do the differentiation.